Hello developers, welcome back to iCoded. So in this video, we're going to implement a infinity scoring feature in a React application from scratch. So the feature itself is relatively common. You can see that in many different applications, websites. It's kind of a established pattern already. So user either on the phone or on the website, and initially the pages like only load a few items, and when you scroll, it will load more. It's kind of linked to the previous video about intersection observer. So we have already, if you haven't yet, please have a look at the previous video to get some basic understanding of the fundamental features behind this. And in this video, we're going to implement the infinity scoring by using this observer pattern. So by the end of the previous video, we have already implemented the simple feature already. It has the static code and it can show the list. We have registered a observer that can check all the list items and the trigger element. But essentially, we are just like running a list of items, and we have a trigger element at the end of the list. And initially, the trigger is hidden because it's out of the root element. So when we scroll and when it's into the root element, we will. So at the moment, we just console log the unit text. It doesn't do much. But yeah, we'll implement a fetching more data when we reach to the bottom. So if we look at the current behavior, so now initially it has only console log the four top elements, and as we scroll, it will add in more content in the console log. And if we reach to the bottom, it has a load more item visible. But in this video, we're going to just fetching data first from the backend, and then gradually adding the pagination stuff on top of that. Initially, we have the demonstration purpose. We have released list items, but we don't actually need this list item to be observed. So we'll get rid of this first. We will not do this anymore. So the only thing we care about in this implementation is the bottom trigger element. So we'll see if it's visible. If it does, we will fetch more data, and until we don't need or we don't have any data available in the server side. We could simplify this a little bit by using another reference. So the trigger will be refed by a ref, just like the container reference. So let's do that. We can define a trigger ref, which will be list item. It's a list item. And then we will assign that to the bottom one. Just give it ref to be the trigger ref, and then we will in a registry we will check like if the trigger reference the current exists, we can observe it by using the current. It will be a HTML element. And we don't need this selector anymore. And because we know that we will only have one entry, so we probably don't need this for each. So we can just use entries 0, which will be the trigger, and we will say if trigger, the entry is 0, which is the trigger, is intersecting. We can simply console log the content for now, and then later on we will add that as a fetch more content. So it's pretty much like this. We can simplify it a little bit like this. If we go to the implementation now and refresh the page, and if we scroll to the bottom, we see that load more. And if we scroll up a little bit and then entry to the bottom, we can see it triggered again. And we can trigger that multiple times when we scroll to the bottom. This is kind of the behavior we are expecting. That's cool. So we now have this kind of structure cleaned up a little bit. So in the use effect block, we're checking current reference is defined, and we will define the options. And then in the callback, we're checking if the target is intersecting with the container. If it does, we'll just console log for now. And at the end of the use effect block, we just disconnect it when the component is on mounting. So yeah, that's pretty much about the current implementation. But now let's fetch all the data from the server side, and then we can, trigger the more page load. So I have already got the backend up and running. So if we have a look at the payload, so we have an API called codes paginated page equals to, let's see, we want to get the page 1 content. You just give it a page equals 1, and you will get a list of codes. And on top of that, we will also have a metadata attached to the response. So it will give you the pagination content information. Like currently it's on the page 1. It has more content to come, and the current page size is 5, and the total count is 49. And if we check the codes now, it has author, ID, and text. And if we go to page 2, we can see it has a different set of codes, and also the metadata change as well. It has more, yes, the current page is 2. And if we go to, because it's like 49 items in total, and each page has 5 items, so it means it has 9 pages. So if we go to page 10, we'll get the last set of the response. We get 4 items because it's 49. And if we go to 11's page, we won't get anything because it's already doesn't have more items. Actually, for the page 10, it doesn't have more page to come. So we can use that as a flag to show the load more button. So yeah, the data structure is pretty much like this. We will need to define some type here first. So now let's define the code type. Let's do that. So it will have the ID is a number, has a text which is string, and author is another string. Also, we will need the metadata, so we will need to define the meta. It has a few items here. Let's do that. So this one will be a string. Ideally, it should be a number, and this one will be a number. Number total is a number, and this is the boolean. And we also need a type to represent this whole structure. We can call it paginated codes, and it has meta, which is meta format, and the codes is a code array, right? So this is final response, paginated codes. All right, so we have this type, and we will need a function that can can fetch the data from the remote. So let's do fetch codes. It will have the page, which will be a number. Initially we give it 1, and it will use the fetch HTTP 3000 codes paginated, and page will be the page, and then we just return the response.json. So now obviously it will be a async function, and yeah, that's pretty much what we need to fetch the data. We can make that promise paginated codes as the response, right? All right, so this is the setup we need for the pagination to happen, and now we will make some change here. So firstly, we will need to store the data to a local instead of using the static ones. So let's define a list. Let's say code list. Set code list is a state. So by default, it will be a code list in the empty by default. And we will need a fetch next function that when you scroll and reach the bottom, we will call that function. So we'll define a function called fetch next, and it will use the page current page, and then it fetched the next page when this happened. So let's do that with because the fetch code returns the metadata and the codes. So we will wait here and fetch codes by let's add a async by a page object. So once we have that page, we will set the code list to whatever the initial code list is, and then add it to the fetched codes, something like this. And once we have done this, we will need to increase the page. Yeah, obviously we don't have the page defined yet. So the page will be we can use a reference as a number reference, and like this use ref, which will be a number. Initially it's 1, and we can use number current, so it will use that page the initial number. And once we have that, and we can change we can increase that page dot current is page dot current plus 1. So it will increase the page, and then it will have more codes to render. And once we have this, we can use the code list instead of the codes here. So code list, the map, and now each item in the code list is a code. So we'll need the ID, and we'll need to render the text, and we also need the code author as a result. So the fetch next will happen when we initially load the page. So we'll need another use effect block. So we'll fetch the first page and render the list. And yeah, let's have a look at the current results in browser. Let me do a refresh here. Okay, and we have these. And let's check the network. Because I'm in a development mode, React will request two times, and we will have this list, which is good. And we have this from the backend. That means so. This is the response from the server side. The first one is the only limit. This is the only limit. And it has only 5. 1, 2, 3, 4, 5. That's good. That's mean we are talking to the backend server. And now let's hook it with the intersecting. So now if the root is intersecting with the load more trigger, and once we have that intersection, we will fetch next. So in here, instead of doing the console log, we will change that to fetch next, right? So now if we go to our application, initially it has 5. If we scroll to the bottom, it fetched a few more. And if we re-trigger that, it fetched a few more. And if we do that again, it seems working in a way. You can see the paginated content is changing, but the problem looks like the page is increasing as well. We can get more data, but seems the content is not correctly set. You see, we only have only one page at a time, so that means we will need to make some change in the codes there. Let's see what is going on. Okay, so we initially the code list is empty, and we get the codes. And once we get that code, we set that to the code list by expanding the current code list. This looks about right. So if we do a code list and return the whole set of list, this is the new data and this is the existing one. And let's have another look. Yeah, it looks like it's fetching more until we get all data. We have another one and we have yet another one. So that means we are over fetched, like because of this feature exist. So we'll definitely need some deduplication to making sure our list is clean. We don't have the duplicate items. And if we keep scrolling, it will increase in the number. Keep doing that. And that's something we want to avoid because obviously we don't have much page than that. So we will need to go back to the fetch next, and we will need to check the meta. So in here, once we have this meta, we will say if the meta though has more, we will need to increase the number. Otherwise, we will stop there, so we don't have to set the incorrect page. So let's do that one more time. So if we go into the tens, and if we keep scrolling, it will be always number 10. Actually, we probably need to see if this has more into a state. And so when we in observer, we can check if it's already doesn't have more, we don't fetch at all. It can happen when we have a has more kind of feature here that has more is false by default, or maybe it should be a true by default. It's a boolean. By default we assume it has more, and when we have fetched, we can set it has more to be meta or to be meta has more, and we can use this has more flag in our intersection here. So if it's intersecting and there are more to fetch, we just fetch, otherwise we just ignore them. And now if we go back to the implementation, we scroll 5, 6, 7, 8, 9, 10. It seems doesn't actually working. That is because we are not re-rendering the component once we have already got the false here. So it's set as false, and because we are not re-rendering, it's always true because that's the last time set value. So if we keep scrolling, it will be always true. Even last time it's already been set as false. And that's why we will need to use another reference value, not the state value. So if it's a state value, it will only being say when you re-render the component. But now the component is now re-rendered, I think. We can fix that problem by introduce another reference here. Let's say it has more, it's a Boolean number, it's a Boolean, and by default it's true, let's say. And then you can set the value directly by saying the current is the method that has more, and that will fix the problem, just like the has more here. But let's have a look at it first. And has more current. If we go to our implementation and in a network request, if we reach to 10, and if you scroll, it won't trigger another fetch because we have already set the has more to true. So this is a little bit tricky here because the value need to get the latest from the reference, not the state. As you can see, that we have to deal with a lot of similar the variables like is currently loading, or are we fetching new data? The list we get is has some duplicated values like you see in console now. So these things are very common, and if we write that from scratch, it will be a super complicated. You have to deal with a lot of status references, and it's very easy to go wrong because at the initial fetch as well, and you will end up with a lot of user effect blocks. And to make that a little bit easier, we could use some libraries like React query. To simplify this, they have a hook called use paginated query, so you can pass in the parameters and use the library to handle the complexity for you. But yeah, for our demonstration purpose, this is pretty much about what you can do if you want to write that from scratch. That's pretty much about this video, and I will probably make another short video about how to do that with React query. But that will be a separate one, I guess. And if you have any questions around the infinity scrolling or other considerations you think I missed, or you want to hear more, please let me know in the comments below. And thanks for watching, and I will see you next time. Bye.